Tonight, we're going to explore something that touches every moment of our lives, yet slips through our fingers like sand. What is time, really? Not the ticking of a clock, not the numbers on your screen, but time, the invisible rhythm behind everything that happens. It never stops, it never waits, it never speaks, but somehow we feel it in every breath, every heartbeat, every passing day. Some say time is an illusion. Others say it's the most real thing there is. Ancient philosophers, modern physicists, poets, and dreamers all have tried to understand what time truly is. And tonight, as you close your eyes or rest your mind, we'll take a slow, quiet journey through the mystery of time. You don't have to do anything. No need to think too hard. Just listen and let your thoughts gently drift. We'll move softly, from ancient myths to scientific theories, from clocks and calendars to the edges of the universe. And maybe, just maybe, by the end, you'll see time in a whole new way. So, take a deep breath and let's begin. Have you ever noticed how time seems to change its shape depending on what you're feeling? Sometimes, an hour stretches endlessly, like waiting at the airport or sitting through a dull meeting. Other times, entire days disappear in the blink of an eye, especially when you're with someone you love or lost in something you enjoy. Why does time feel so flexible, so emotional, when the clocks around us remain steady? Let's take a deep breath together and explore how human beings experience time, not through numbers or physics, but through feeling. The mind's clock, long before we had watches, calendars, or even sundials, we had something far more ancient, the sense of time within our own minds. Your body, your brain, your very cells, they all follow rhythms. There's a quiet orchestra inside you, ticking, pulsing, counting. Scientists call it the circadian rhythm, the internal clock that guides our sleep, our hunger, our alertness. It resets with the rising sun. It softens when night falls. Even before you knew what a minute was, your body already knew the difference between day and night, work and rest, action and stillness. Why time feels different? Now imagine this. You're a child again, summer break. The days feel endless, bright, wide, and open. Compare that to now. Perhaps you're older. Years seem to pass before you even realize they've begun. January turns to June. June slips into December. Another birthday. Another year. What changed? Neurologists believe it's partly memory. When we're children, everything is new. The brain takes in more detail. Time feels slower because it's rich, packed with sensations, moments, firsts. As adults, we form routines. Days blend into each other. The brain stores less detail, and so, time feels faster. It's not that the clock moves differently, it's that our attention does. Time and attention. Here's something curious. Studies show that when we focus on time, like watching a countdown or staring at the clock, it feels slower. But when we're distracted or deeply engaged, reading, laughing, dreaming, time rushes past like a river. In other words, time, at least how we feel it, is tied to attention. This is why mindfulness, simply being present, can stretch out a moment. And why anxiety, constantly jumping from one thought to the next, can make time disappear. Our perception of time is not fixed. It breathes, just like we do. Why we remember the past, not the future. Let's go a little deeper. Why do we remember the past, but not the future? It seems obvious. But from a purely logical perspective, it's a strange rule. If the universe allows events to happen forward in time, why not backward? Why are our memories always behind us? One theory comes from physics: entropy, the tendency of things to move from order to disorder. A shattered glass doesn't unshatter. Smoke doesn't return to the cigarette. Memories, likewise, don't move in reverse. But there's also something more emotional here. Our brains are built to record and reflect, not predict with certainty. We dream about the future, but we remember what was, not what will be. That's the human condition. We're always arriving, but never quite ahead. Sleep and the stretching of time. Have you ever woken up from a dream that felt like hours, only to find out you were asleep for 10 minutes? Time in dreams has its own logic, or none at all. Sometimes you jump years in a second. Other times, a single conversation seems to last forever. Why does this happen? In dreams, the part of our brain that tracks time, the prefrontal cortex, becomes quiet. The boundaries of time dissolve. You drift. You float. You enter a space where time is more like a feeling than a fact. Time and memory, the tape recorder illusion. Think of your memory like an old cassette tape. But here's the twist. It doesn't record everything. In fact, it barely records anything in full. It's selective, biased, messy. You remember your first kiss, but not what you had for lunch 3 days ago. You remember the pain of losing someone, but you forget their phone number. Why? Because memory isn't made to store time. It's made to make meaning. Your brain captures the emotional highlights. It builds a story, not a timeline. So when you look back at your life, you don't see a perfect record. You see a narrative, shaped by feeling and sculpted by time. The illusion of now. Let's pause for a moment. Right now. As you're listening, ask yourself, what is now? Is it this word? This breath? This sentence? Neurologically, the brain takes a little time to process signals. The light hits your eyes. The sound reaches your ears. Your brain interprets it. That means even in the moment you call now, you're already slightly behind. You live ever so slightly in the past. Our sense of now is stitched together from tiny delays. So maybe there is no true present, only the mind's best guess, a flickering candle in the river of time. How we shape time. And how it shapes us, isn't it strange? We invented clocks, but clocks now control us. We invented schedules, but they define our worth. We race the hours. We chase the days. We set alarms for our dreams. But time, real time, doesn't care about numbers. It moves quietly, through your breath, through the wind, through the stars. And still, we try to hold it, capture it, make it ours. Maybe that's the beauty of it. We try to shape time, but time, in the end, shapes us. So as you lie here now, or simply listen in stillness, remember this: time, as you feel it, is a story your brain tells, a soft rhythm in your thoughts, a gentle wave that you ride. You don't need to control it. You don't even need to understand it. Just let it carry you, quietly, calmly, forward. Time feels so modern, doesn't it? Watches, phones, calendar alerts. We've made it digital, mechanical, programmable. But long before clocks ticked or calendars flipped, humans were already watching the skies and asking the same question we ask tonight. What is time really? So now, close your eyes and imagine you're walking barefoot through ancient sand. There is no electricity, no cities, no satellites, just the earth, the stars, and your thoughts. And above you, the sky slowly turns. Let's go back to where our story begins. Time before time. In the very earliest human cultures, time wasn't something you measured. It was something you lived. The rising and setting of the sun was the heartbeat of the world. The phases of the moon marked the flow of months. The seasons came and went like breaths in a sleeping giant. People woke with the dawn and rested with the dusk. There were no minutes, no seconds, only cycles, rhythms, nature's quiet patterns. Time wasn't linear. It was circular, like the moon, like the seasons, like life. The moon, the mother of time. Long before humans tracked the sun, they watched the moon. It changed visibly. A soft, glowing calendar in the sky. Every 29.5 days, it completed a cycle, full to empty, and back again. Many ancient cultures used lunar calendars. Each moon phase had meaning. Each change in the sky told them when to plant, when to harvest, when to rest. In ancient Mesopotamia, Babylonian priests recorded lunar phases on clay tablets. They were among the first humans to connect the heavens with time. Even today, the word month comes from the word moon. The sun and the solar timekeepers. The sun, too, was more than light. It was a clock in the sky. In Egypt, obelisks cast shadows that moved with the sun, early sundials. The length of the shadow told them what time it was. But for the Egyptians, time wasn't just measurement. It was sacred. They believed the sun, god Ra, sailed across the sky by day and through the underworld at night. Each sunrise was a rebirth. Each sunset, a journey through the unknown. To them, time was divine, not mechanical, but spiritual. The Greeks, time has two faces. The ancient Greeks had two words for time: chronos, the measurable, numbered time, and kairos, the right moment, the meaningful time. Chronos was the ticking of the clock. Kairos was the feeling in your heart when something felt meant to happen. One was quantity, the other quality. They believed that not all moments are equal. Some carry weight, some are empty, and some are filled with destiny. Can you feel the difference between time that passes and time that matters? The Mayans. Time is a sacred cycle. Let's journey now to the jungles of Central America. The ancient Maya civilization had one of the most complex time systems ever discovered. They didn't use just one calendar. They used three, all at once. 1. The Zolkin, a 260-day sacred calendar for rituals and ceremonies. 2. The Hab, a 365-day solar calendar for agriculture. 3. And the long count, to measure vast stretches of time, even millions of years. For the Maya, time was alive. Every day had its own energy, its own purpose, its own personality. They believed the universe moved in great cycles: creation, destruction, rebirth, just like day and night, just like the moon, just like you and me. The Islamic calendar, time as devotion. Now drift to the deserts of 7th century Arabia. The Islamic calendar, or Hijri calendar, is purely lunar, 12 months, each tied to the moon's cycle. It begins not with a birth, but with a journey. The Hijra of Prophet Muhammad, peace be upon him, from Makkah to Medina. Time here is not just physical, it's moral. It's a path toward truth, toward accountability, toward the Creator. 5 times a day, Muslims pause to pray, not by the clock, but by the sky. Sunrise, noon, afternoon, sunset, night. Time becomes rhythm. Worship becomes timekeeping. And time becomes a reminder of purpose, of patience, of passing. The Hindus. Time is infinite. In the Indian subcontinent, Ancient Hindu philosophy sees time not as a straight line, but as an endless circle. They call it kala. Time is a cosmic force. According to their tradition, the universe moves in enormous cycles called yugas. Satya Yuga, the age of truth. Treta Yuga, the age of sacrifice. Dvapara Yuga, the age of doubt. Kali Yuga, the age of darkness, the one we're in now. Each cycle lasts thousands, even millions, of years. Time, here, isn't just cosmic. It's eternal. And humans are not outside of it, but flowing within it like drops in an ocean. Measuring time? A human obsession. Why did humans start measuring time? To organize, to control, to understand. Maybe all three. In ancient China, water clocks dripped steadily, each drop a heartbeat of time. In Persia, candle clocks burned slowly, each inch a silent countdown. But still, even with these clever inventions, time wasn't just counted. It was felt. It was respected. It was sacred. Myths and legends of time. Almost every culture has a myth of time. In Norse mythology, time ends in Ragnarok, the twilight of the gods. In Hinduism, time is personified as Shiva, who dances the universe into destruction and creation. The Greeks told of Kronos, who swallowed his children, time devouring all things. Each story is a mirror, reflecting our deep fear and fascination with time's power. Because time creates, but it also destroys. And in its silent passing, it reminds us of everything we love. From the stars to the wristwatch. It's humbling, isn't it? That all our smartwatches, our global clocks, our deadlines and schedules, all of it began with a shepherd watching the stars, a farmer reading the wind, a priest marking moonlight on stone, a mother waiting for her child to return before sunset. Time has always been more than just numbers. It has been feeling, pattern, presence. So tonight, as you lie still, know that you are connected to something ancient, something timeless. The tick of your heartbeat echoes the sun. The rhythm of your breath follows the moon. You are not outside of time. You are part of the same dance that turned the stars for the Egyptians, that moved the calendars of the Maya, that whispered to the philosophers of Greece, and that still, even now, guides your every step. Close your eyes for a moment and imagine a world without clocks, no ticking on the wall, no alarms, no 9 to 5, no countdowns, just the sun, the wind, the passage of shadows. Now ask yourself, when did we decide to count time? When did we stop flowing with it and start managing it? This is the story of how we turned the sky into a calendar and time into a machine. Before the clock, time is a feeling. For most of human history, time was measured with the body, the squint of eyes at the rising sun, the hunger at midday, the weariness at dusk. Farmers woke with the birds. Fishermen watched the tide. Mothers knew the passing of months by the rhythm of the moon. There was no need to rush, no need to slice the day into tiny slivers. Time was not a master, it was a companion. But as civilizations grew and life became more complex, humans began to ask, can time be measured, captured, owned? Sundials and shadow time. The first true instruments of time were not machines. They were stones, sticks, shadows. In ancient Egypt, obelisks, tall stone pillars, were placed to cast shadows on the ground. As the sun moved across the sky, the shadows shifted, and people could tell the general time of day. Later, sundials refined the idea. A metal rod called a gnomon cast a shadow on a circular plate. The shadow pointed to hours, marked like a clock face. But sundials had one flaw. They only worked when the sun was shining. So night was timeless. Or was it? The water clock. Time begins to drip. To track time in darkness, ancient engineers turned to something universal: water. In Mesopotamia, India, China, and Greece, water clocks were developed. Here's how they worked. A container, filled with water, slowly dripped through a small hole into another vessel. As the second vessel filled, the water level rose and marked the passing of hours. It was simple, beautiful, a gentle stream, measuring time drop by drop. In China, some water clocks even rang bells or moved mechanical figures as time passed. A precursor to automation, time had become predictable. And that changed everything. Candles, sand, and time you can see. Born in ancient Persia, Japan, and Europe, time was measured with candles. Each candle was carefully measured. As it burned, marks on the side would indicate the passing of hours. In some palaces, small metal balls would drop from the wax at regular intervals, striking gongs or chimes. And of course, there was the hourglass, a symbol of time itself. 2 glass bulbs, sand trickling from one to the other, a perfect image of time slipping away. But here's the truth. These weren't just timepieces. They were meditations, visual calming reminders that time is always in motion. The calendar, time across days. Now step back. A clock divides hours, but how do you divide years? Enter the calendar. Ancient civilizations each created their own way to mark the passing of months, seasons, and years. Let's look at a few. The Egyptian calendar. Solar science. Ancient Egypt used one of the first 365-day solar calendars. It had 12 months of 30 days each, with 5 extra festival days added at the end of the year. These extra days were considered sacred, existing outside of time, a kind of pause between the cycles. Their new year began with the flooding of the Nile, a moment that brought life, water, and time itself. The Roman calendar, a political clock. The Roman calendar began as a lunar system, but it was messy. Months didn't match the seasons. Festivals drifted. Farmers got confused. So Julius Caesar reformed it in 46 BCE, creating the Julian calendar, a solar calendar with 365 days and a leap year every 4 years. It worked better, but not perfectly. Over centuries, it drifted by 11 minutes each year. By the 1500s, spring was arriving 10 days too early. So Pope Gregory XIII stepped in and introduced the Gregorian calendar in 1582, the one we still use today. A small shift, but one that realigned the world's sense of time. Lunar versus solar, 2 visions of time. While Europe embraced the solar calendar, many cultures, including the Islamic world, stayed with the lunar. Why? Because the moon is visible. It doesn't need math. It simply appears. The Islamic calendar, based on 12 lunar months, is about 11 days shorter than the solar year. This means holidays like Ramadan move through the seasons over time, reminding Muslims that time is not fixed, but flows. Mechanical clocks. Time becomes a machine. Let's return to Europe. The year is 1335. The place? Milan. In a bell tower, a new kind of timekeeper ticks for the first time. A mechanical clock. It uses gears and weights instead of water or shadows. It rings bells at regular intervals. And slowly, cities all over Europe begin to install them in cathedrals and towers. Why? Because for the first time, time could be heard. The bell became the heartbeat of the town. People woke, worked, and worshipped by its rhythm. Time had become public and powerful. The shift. Time starts to rule. Us. This was a turning point. Before clocks, time was lived. After clocks, time was watched. The Industrial Revolution pushed it further. Factory bells rang at exact hours. Trains ran by strict schedules. Watches became common. Punctuality became a virtue. Suddenly, being late was not just inconvenient. It was wrong. Time had become not just a guide, but a boss. Standard time. The world sinks. Up in 1884, world leaders met in Washington, D.C. to agree on something radical: global time zones. They decided the world would be divided into 24 zones, each 1 hour apart. The prime meridian, 0 degrees longitude, would run through Greenwich, England. From then on, trains, ships, and businesses could all sync up. No more guessing the time in Paris or New York. But this decision also froze time. It made time universal, but also artificial. In many ways, the sky no longer mattered. Only the clock did. The wristwatch and the war clock. In the 20th century, the wristwatch became more than fashion. It became survival. During World War I, soldiers needed to coordinate attacks down to the minute. Pocket watches were too slow, so watches moved to the wrist. After the war, they became everyday items, status symbols, instruments of precision, and soon, time was always on us, always ticking. Digital time, always connected. Now, time is everywhere, on your phone, your microwave, your wrist, even your refrigerator. We check the time dozens of times a day, often without realizing it. Time doesn't just guide our day, it invades it. We schedule sleep. We plan joy. We track steps, heartbeats, productivity. And yet, despite all this control, we still feel like we're running out of time. Why? Because in making time mechanical, we made it scarce. The return of slow time. But here's the quiet truth. Time was never meant to rush us. The slow food movement, meditation, mindfulness, digital detoxes. These are signs that deep down, we remember what ancient people knew. That time is not just for measuring, it's for living. A sunrise doesn't care about your calendar. A breeze doesn't ask your schedule. A moment of peace has no timestamp. Sometimes, the best way to understand time is to stop watching it and simply be. So, as we end this chapter, think of all the forms time has taken. A dripping pot, a burning candle, a ringing bell, a glowing screen. And know this, time has never really been about machines. It has always been about you, how you feel it, how you carry it, how you let it shape your story. Take one long, deep breath, because in this moment, there is no rush, no deadline, only now. What if I told you that time is not what you think it is? That what feels steady is not steady? That what seems simple is one of the most mysterious forces in the universe? Tonight, let's drift away from calendars and candles and enter the world of physics, a world where time bends, stretches, and sometimes even disappears. So, take a deep breath and let's step into the mind of the cosmos. Newton's time, the invisible clock. For over 200 years, time was considered absolute. Sir Isaac Newton, the father of classical physics, imagined time as a kind of invisible clock, always ticking, always steady, independent of everything. To Newton, time was like a stage. Events happened on it, but time itself stayed untouched. A kind of divine rhythm, always the same, everywhere. Whether an apple fell in London or a comet soared through the stars, time ticked onward, undisturbed. It felt safe, predictable, almost eternal. But that idea wouldn't last forever. In the early 1900s, a young patent clerk named Albert Einstein looked at time and asked a dangerous question. What if time isn't absolute at all? What if time depends on where you are and how fast you're moving? His answer became the theory of relativity, and it changed everything. Einstein showed that time is not separate from space. Instead, they're woven together into something called spacetime, a kind of fabric that stretches and curves. And here's the twist. The faster you move through space, the slower you move through time. Time dilation. The faster you go, the slower you age. It sounds like science fiction, but it's very real. Imagine two twins. One stays on Earth. The other gets on a spaceship, traveling near the speed of light. Years pass. When the traveler returns, they're younger than their twin. Why? Because time passed more slowly for them while they were moving fast. This is called time dilation, and it's been proven in real experiments. Even GPS satellites floating high above Earth experience time a little differently than we do on the ground. Their clocks have to be adjusted because gravity and speed affect time itself. The slower flow of time, near gravity. But motion isn't the only thing that affects time. Gravity does too. The stronger the gravity, the slower time flows. Near a black hole, one of the densest, most extreme objects in the universe, time slows almost to a stop. This means if you stood near a black hole for just a few minutes and then returned to Earth, you might find that years had passed for everyone else. In one place, minutes; in another, decades. Time, in Einstein's universe, is no longer a river flowing at a steady pace. It's a wild, flexible thing, stretching, slowing, warping. Relativity's deeper meaning. Relativity teaches us something humbling. There's no universal now. No single perfect moment shared by all. Two people, moving differently or standing in different gravitational fields, might literally disagree about when something happened. Reality becomes relative. Truth becomes location-based. It's as if each person carries their own timeline, and the universe respects them all. So, what is time? Even with all this knowledge, physicists still don't fully understand what time actually is. Some believe time is an illusion, a side effect of how our brains perceive change. Others think it's a real dimension, like space, that we simply move through, one moment at a time. And some even propose that the universe doesn't move at all, but every moment exists all at once, like pages in a book. We're just reading it, one line at a time. The quantum problem. In the world of quantum physics, where particles blink in and out of existence, where uncertainty rules, time gets even stranger. Some quantum theories don't require time at all. In their equations, events just exist, and time is something that only emerges when you zoom out. In other words, at the tiniest level of reality, time might not even be real. It might be a story we tell ourselves. The block universe. Theory. Here's an idea both beautiful and terrifying. It's called the block universe. It suggests that past, present, and future all exist simultaneously, like a frozen 4D block. Not something that flows, but something that is. From this view, you're not moving through time. You simply are, in one slice of a larger structure. The past hasn't disappeared. The future isn't waiting. Everything just exists. It's not how we live, of course, but it may be how reality truly works. What does it mean for us? So, what do we do with all this? With time that stretches and shrinks, that flows slower near black holes, that might not be real at all? Maybe the lesson isn't to understand time, but to feel it, to live slowly, not because physics demands it, but because life deserves it. To remember that time, for all its complexity, is also a gift, a moment, a breath, a chance to notice what's here, now. So as this chapter ends, let go of the ticking clock. Let go of calendars and coordinates. Instead, imagine time not as a line, but as a sea. You're floating in it. And maybe, just maybe, you don't need to rush, because wherever you are is exactly where you're meant to be. Close your eyes and think about this moment. Now it's gone. You can't hold it. You can't rewind it. It is past, and the next moment is already here. But why? Why does time move forward and never in reverse? Why can you remember the past, but not the future? Tonight, let's follow the quiet trail of the universe's most mysterious force and trace the arrow of time. What is the arrow of time? In science, the arrow of time means that time flows in one direction, from past to future. You are born, you grow, you age, you die. An egg falls, it cracks, but never uncracks. We call this direction the thermodynamic arrow, and it's deeply connected to a strange concept called entropy. Entropy, the measure of disorder. Imagine a child's clean room. Everything is folded, toys are in place, it's organized. Now imagine that same child, 2 hours later, toys scattered, clothes thrown, crumbs on the floor. The room has moved from order to disorder. That's entropy. And in the universe, entropy is always increasing. Things naturally become less organized over time. Hot tea cools, ice melts, buildings crumble, stars die. Everything tends toward chaos, not because of carelessness, but because of physics. The second law of thermodynamics. This law says, in a closed system, entropy will either stay the same or increase. It never decreases. This is the secret behind time's arrow. It's not clocks. It's not calendars. It's entropy, always growing, never shrinking. It's why we remember the past, where things were more ordered, but can't see the future, where things are still undecided. Entropy is the universe's memory and its future. Why can't time go backward? You might ask, but aren't the laws of physics reversible? Yes. At the microscopic level, most equations work the same forward or backward. But the universe as a whole isn't symmetric. Because of entropy, events are overwhelmingly more likely to go forward. There are billions of ways for a plate to shatter, but only one perfect way for its pieces to leap back together. The universe doesn't forbid time reversal, it just makes it almost impossible. Time and memory. Interestingly, our brains also follow the arrow of time. We can only form memories after events increase entropy. You remember cracking the egg, not the egg being whole. Time, for us, is not just physics, it's experience, and that experience is one way. The universe is beginning. Low entropy. But here's the mystery. If entropy always increases, then why was the early universe so incredibly ordered? The Big Bang began with low entropy, an almost impossibly perfect, smooth, dense state. Why? No one knows. It's one of the biggest unanswered questions in physics. Some say it was a cosmic fluke. Others believe it hints at deeper laws we haven't discovered yet. But one thing is clear. The arrow of time began at that moment, and it's been stretching forward ever since. A final thought. So, why does time only go one way? Because the universe is unraveling, not in sadness, but in motion. From stars to dust, from order to mystery, from yesterday to tomorrow. The arrow of time is written into the very fabric of reality, and we are all riding on it. Every breath, every heartbeat, every fading memory, all part of the great unfolding. So as we end this chapter, don't fight the current. Don't fear the flow. Time is not your enemy. It is the rhythm of becoming. The arrow that points you forward toward whatever comes next. Close your eyes and imagine stepping into a machine. You pull a lever, and the world around you begins to shift. Moments blur, years pass, centuries vanish. You step out, and everything is different. You've traveled through time. But is that just a dream? Or could it be real? Tonight, we explore one of the oldest and wildest human fantasies, time travel. The ancient dream. Long before science had words for it, humans were already imagining time travel. In old myths, heroes slept for hundreds of years, or found magic rivers that flowed backward through time, to escape death, to fix the past, to see the future. The idea was always there, in our stories, our hearts, and our deepest longing. Einstein's universe, time isn't fixed. Then, in the 20th century, science caught up with imagination. Einstein showed us that time is not fixed. It can slow down, it can bend, and maybe, just maybe, it can loop. In general relativity, massive objects like stars and black holes bend not just space, but time itself. Under extreme conditions, a path might exist that takes you not just forward, but back. Physicists call these paths closed time-like curves, loops in spacetime that could, in theory, let you return to an earlier point. In theory. Wormholes, shortcuts through time. Another idea, wormholes. These are theoretical tunnels connecting two distant points in space and time. Imagine folding a piece of paper and poking a hole straight through it. Instead of traveling across the paper, you jump instantly from one side to the other. A wormhole could, in theory, be that hole. And if one end of the wormhole is moving faster than the other, time inside might pass differently on each side. You enter at one end in 2025 and come out the other in 2125, or maybe 1925. It sounds wild, and it is, but math doesn't rule it out. The grandfather paradox. Of course, time travel isn't just a science problem. It's a logic problem too. Let's say you go back in time and stop your grandfather from meeting your grandmother. Then, you're never born. But if you're never born, how did you go back in time? This is the grandfather paradox, a loop of logic with no easy answer. Some scientists believe that time protects itself, that any action you take in the past will automatically prevent paradoxes. Others suggest alternate timelines, parallel universes that split every time a change is made. You don't change your past, you just create a new future. Time travel in fiction. Movies and stories have had fun with these ideas for decades. In Back to the Future, a boy nearly erases his own existence. In Interstellar, gravity bends time across planets. In Tenet, time runs backward, even as the world moves forward. In Arrival, language changes how time is experienced. These stories aren't just entertainment. They're reflections of our deepest questions. Can we fix our mistakes? Can we know what lies ahead? Is time really as rigid as it seems? Is time travel possible? So, is time travel possible? Let's be honest, we don't know. Forward time travel, thanks to relativity, is already real. Astronauts in orbit age slightly slower than we do. It's tiny, but measurable. Backward time travel? Much harder. Wormholes require exotic matter, something we haven't yet discovered. And the energy needed would be beyond anything we can currently imagine. But here's the strange part. Physics hasn't completely ruled it out. So maybe it's not impossible, just not yet possible. The power of imagining time. Even if we never build a time machine, there's something beautiful in the idea. Because time travel isn't just about machines. It's about memory, regret, hope, imagination. We travel in time every day, whenever we remember someone we loved, or dream about the person we want to become. Our thoughts move through past and future, even when our bodies can't. And maybe that's its own kind of time travel. So, as we end this chapter, don't be afraid to imagine, to wonder, to drift through time with nothing but your mind, because the journey is already within you. Every dream, every memory, every quiet moment between heartbeats. We're all time travelers. We just move 1 second at a time. And now, we've come to the end of our journey. Not the end of time, but the end of this quiet moment we've shared together. We've wandered through ancient myths, walked beside scientists and philosophers, felt the ticking of clocks, and stretched our minds across stars and wormholes. And yet, for all the theories, equations, and dreams, time remains a mystery, a silent river that carries us all without asking permission. Perhaps that's what makes it beautiful. Not that we can control it, but that we can feel it. Hold it for a moment, in a memory, a breath, a heartbeat. There's something tender about knowing that this very second, right now, will never come again. And yet, you're here. You lived it. You were present. Maybe that's all we really have. Not the past we wish to change, not the future we fear or chase, but this moment, this small, fleeting moment where everything simply is. So wherever you are, whether you're lying in bed or resting your eyes after a long day, I hope you carry a little peace with you from this journey through time. Because time is not just about seconds or centuries. It's not about clocks or calendars or cosmic physics. Time is a feeling, a presence, a soft reminder that you are here, right now, in this quiet, in this breath, and in a world that moves so fast. Maybe the greatest act of all is to simply slow down and notice it. Thank you for traveling through time with me tonight. Sleep well, or rest gently, and remember, no matter how fast time moves, this moment is always yours.